All right, let's just jump right in. We are living in this wild age of AI, right? I mean, these things can write code, they can create incredible art, they can answer just about anything you throw at them. But, and this is a big but, there's a paradox here. As these AIs get smarter, their mistakes, they're getting way, way harder to catch. We're not talking about simple glitches anymore. This is a whole new, much trickier ballgame, and we've got to get a handle on it.
And this quote, this right here, this nails the core of the problem. Look, it's not that AI gets things wrong. Of course it does. Every system has bugs. The real issue is how it gets them wrong. You see, the latest models, we're talking GPT-4o, Gemini, all the big ones, they can fail with so much confidence, so much polish, that the wrong answers look, well, they look exactly like the right ones.
So think about it. What we used to worry about were the obvious mistakes, right? The glitchy, nonsensical stuff that you could spot a mile away. But that's not the real danger anymore. What's truly dangerous is the plausible, confident lie. It's when an AI gives you an answer that sounds perfectly clear, the logic seems totally solid, but the final conclusion is just flat out wrong. And those are the mistakes that sneak right by us because, honestly, they don't set off any alarm bells.
So, okay, if the big problem is these super subtle, really convincing failures, how in the world do you fight that? I mean, you can't fix a problem you can't even see, right? Well, that's where a totally new approach comes into play. One that is all about collecting and cataloging these sneaky mistakes and then turning them into a tool for making things better.
And here it is. This is Codada's LLM Failure Cases dataset. Now, the best way to think about this, it's like a library, but instead of books full of success stories, it's a meticulously curated collection of failures. It's built for one reason and one reason only, to capture those really tough-to-spot moments where the biggest AI models just completely mess up. The whole point is to learn from those mistakes.
Now, here's what makes this data set so incredibly powerful: where the data comes from. Okay, this isn't some theoretical academic exercise. No way. These failures were sourced from real users who were creating what are called adversarial prompts, basically questions designed specifically to try and break these models, to push them to their absolute limits. So yeah, this is data straight from the front lines.
Okay, so you might be wondering, how does a library full of failures actually help build a better AI? That's a great question, and the answer is all about the structure. It's about how they deconstruct every single mistake, turning each error into a really powerful learning opportunity.
And this process is just brilliant in its simplicity. Every single entry in the dataset is broken down into 3 easy steps. First, you've got the adversarial prompt. That's the tricky question someone asked the AI. Second, you see the model's flawed response, the confident mistake. And then third, and this is the key part, you get an expert critique that breaks down exactly what went wrong and why. It's a perfect feedback loop for learning.
And we're not just talking about one kind of problem here. Oh no, the dataset covers this huge range of really complex fields where getting it right is absolutely critical. We're talking about subtle failures in things like physics, math, really complex logic problems, and even deep scientific reasoning. It just goes to show you how widespread these convincing, plausible errors really are. And here's another really important point. This isn't about singling out or targeting any one model. The dataset tracks failures across all the major players. GPT-4o, Gemini, Claude, the whole crew. And what that does is it lets researchers directly compare how they behave and start to understand the unique weak spots of each and every system. But wait, there's actually another layer to this. The whole dataset is bilingual, with support for both English and Chinese. Now, this is so crucial because it lets us study how these kinds of logical mistakes might show up differently across languages, across different cultural contexts. And that's a super important and frankly often overlooked part of AI safety research. All right, so let's pull back for a second. We have this huge, incredibly detailed catalog of AI screw-ups. So what? Why does this even matter? How does collecting a bunch of failures actually build success? Well, this is where the rubber meets the road. You see, developers and researchers are already putting this data to work in some really critical ways. For starters, they use it to evaluate new models. They use it to red team their own systems, which basically means throwing the absolute toughest problems at them to see where they break. And they use it for something called RLHF, which is a fancy way of saying they use it to fine-tune the AI. Oh, and it's an absolute goldmine for anyone researching AI hallucinations. And this quote, it just perfectly captures the huge shift in thinking that's going on. For so long, building AI was all about rewarding it for getting answers right. Give it a treat when it's good. But this whole approach, it just flips the script completely. It says that if we ever want to get to the next level of AI reliability, we have to become absolute experts at understanding and learning from the mistakes. And really, that's the path forward, isn't it? Building AI that we can actually trust? Well, it's not about pretending these systems are perfect, not at all. It's about having the humility to embrace their failures, to study them like crazy, and to build systems that are strong and resilient because they've learned from every single one of their mistakes.
So that leaves us with a pretty big question to chew on, doesn't it? We are literally teaching AI how to learn from this massive library of its own mistakes, from tiny flaws in logic to big errors in physics. As it gets better and better at this, what's the one mistake, the one confidently wrong answer that we simply can't afford for it to make? Really makes you think.